Hello there. Today's topic is quadratic equations. Quadratic equation is a second degree equation in which it is one of the important equations in mathematics. Understanding quadratic equation is a basic for most of the advanced mathematics such as calculus. It is easy and interesting. Let's see what it is. A quadratic equation is an expression of the form ax squared plus bx plus c, this one here, where, as we have discussed it in linear equations of two variables, if you remember, the letters here, a, b, and c, represent constants, to mean they are just numbers. And then the variable here, x, is called a variable which can represent any number. Which number is a variable representing is a question of solving a given equation. Well, we can also write quadratic equation in the form of ax squared plus bx plus c is equal to 0. This is an equation form. When we have to solve a given quadratic equation, we need to compare the expression here in terms of a certain other expression or number. This is an equation form. Or we can still write it in the form of y is equal to ax squared plus bx plus c. This one is a form of a graph or a function. Y can represent the vertical value in a Cartesian axis, and then that's also called a function. We can call it a function f of x, g of x, whatsoever. So it's a kind of comparison. We compare y in terms of x, and this is a form of, in fact, a graph. What we mean by saying an equation or a graph whatsoever here will be explained very well as we go deeper and deeper. So a, b, and c are constants, and x and y are variables that represent more than one value. Constant a should be different from 0. We've said that in a linear equation, say in the form of ax plus b y plus c, I can say, is equal to 0 or whatsoever. Both a and b cannot be 0 at the same time. We've said it. At least we need one variable to have a coefficient of different from 0. Anyway, both a and b cannot be 0 at the same time. This is what we've said in a linear equation. Here also in a quadratic equation of the form ax squared plus bx plus c is equal to 0, a should be different from 0, because in case if a is 0, that means 0 times x squared is 0. This part will be 0. So what we have is bx plus c is equal to 0. This is going to be the only thing we will have. Bx plus is equal to 0, which is not a quadratic equation, which is a linear equation, in fact. So in a quadratic equation of the form ax squared plus bx plus c is equal to 0 or whatsoever, the value of a should be different from 0. In a quadratic equation of the form ax squared plus bx plus c is equal to 0, or simply we say it ax squared plus bx plus c, the name of a is a leading coefficient of the equation. That is because it is a coefficient of the highest degree. The highest degree of a quadratic equation is 2. The one which we see here, that is 2. Okay, the same equation can be expressed as ax squared plus bx here, x having no exponent up here means the exponent is just 1. Here in this place we have 1 here, plus cx. We only write here c as a constant because the next variable, which is x, has a degree or an exponent of 0. Any number into the power of 0 is 1. 1 times c is c, so no need to mention x to the power of 0. When I say any number to the power of 0, that does not include again 0, which we discussed it in probably exponential functions, not in here. Because here, the reason is that x to the power of 1 is x. X to the power of 0 is 1. I just define it here as x to the power of 0 is 1 except 0. Except 0, because 0 to the power of 0 is undefined. So x to the power of 0 is 1 other than 0. X should not be 0 in that case. Here, x squared plus bx to the power of 1 plus cx to the power of 0 is the same as ax squared plus bx plus c. So in the next sessions, we're going to say ax squared plus bx plus c. No need to mention x to the power of 1 or x to the power of 0. So we simply define it as ax squared plus bx plus c is equal to 0. What is a, b, c? What is x? As we have said it, a, b, and c are constants, and b is x is a variable. X squared to mean it's a quadratic equation. A quadratic equation is an equation of second degree. It's having a degree of 2. Okay, what is the degree of this equation in general is we consider the highest degree of this. So here we have what? Ax squared, we have 2 here, plus bx, we have 1 here, plus cx to the power of 0, we have 0 here. We can have the degrees or exponents up to 1 and 0. But the degree of this equation is we just take the highest one, wherever it is. It is in the middle, it is at the end of this expression, doesn't matter which one is the highest degree of that equation is the degree of the equation. Okay, we're at page number 2 now. All right. In an expression of, say, ax squared plus bx plus c, a is a leading coefficient because it is a coefficient of the highest degree. Therefore, the leading coefficient, which is a coefficient of the highest degree, should be different from 0. When it is 0, that's no more a quadratic equation. It's going to be a linear equation. Solutions of a quadratic equation, I'm here now, are values when we put them in place of the variable, they satisfy the equation, which we have said it in linear equation session. So that is the reason why other names of a solution set is a truth set. A truth set. Next page. A truth set values of a quadratic equation is geometrically the values of x where the graph intersects on a Cartesian plane. The graph of a quadratic equation is normally an upward or a downward open parabola as follows. Here we have an example of an upward parabola. Equations of this parabola from top to the bottom here. 1 is here, y is equal to x squared plus 2. This is a 1 here. The first one here, y is equal to x squared plus 2. When we try to find the y-intercept of this graph, we have to give 0 for the x because the y-intercept is where the graph intersects with the y-axis. That is on the y itself. In this line, the value of x is 0. When we see here, upward, the value of x is 0. So when we're interested in solving or finding out the y-intercept, we have to put 0 in place of x. When we put 0 here in place of x, 0 square is 0. 0 square, which is 0, plus 2 is 0 plus 2, which is 2. So the y-intercept is 2, means the value of x is 0 and the value of y is 2. We simply call it 0, 2. Here it is. So y is equal to x squared plus 1. When we put again here 0 in place of x, we will be having y is equal to 1, or 0, 1 is a y-intercept. Other than this, this is just a graph of a quadratic equation which opens upwards. More about the graphs of a quadratic equation will be discussed later, so we don't need to worry much about this one now. The real true sets of this parabola from top to bottom are real true sets. When we discuss about understanding numbers, there are of numbers named real numbers. When we say real truth set means a truth set which is a real number. So real numbers are those numbers which are on the y-axis up here and on the x-axis up here. These are real numbers. It can be anywhere within the axis. So how many real number truth sets we can have on this parabola? The first one, the real set means a place where the graph intersects the x-axis. That is, an intersection point between a graph and the x-axis is the solution set of a given graph. So the first graph up here, the top one, is not intersecting x-axis. So the real solution set for it is none. Second one, same, none. The third graph here, it's intersecting the x-axis just at one point. It just only touch it. So we have one real solution set for it. And then the fourth one up here, it intersects at two places. There is two place intersection between the graph and the x-axis. So this graph will be having two real solutions or true sets. The last one is the same. It will be having again 2. Once again, we discuss more about these things and other characteristics of a parabola as they shift to the left, to the right, moving up and down, whatsoever characteristics, the highest point, the lowest points and all. We discuss them later on within this quadratic equation session. The values of x where the graph intersects the x-axis and it is clearly seen. Properties of the graphs of a downward parabola are nearly the same. We see one example below. This one, the characteristic of a downward parabola is the same as the characteristic of an upward parabola. This parabola, which is a downward one up here, y is equal to minus 2x squared plus 12x minus 18. It is a downward parabola touching the x-axis at exactly one point. It means that the solution set of this parabola is just only one number. It will be having only one real solution set. This is what I write it down here. It intersects the x-axis only at one place. The place of intersection is namely x is equal to 3 and y is equal to 0. Here it is an x-axis up here. X is equal to 3. What about the value of y at exactly this point? Look up here. Y is equal to 0. This point of intersection is x is equal to 3, y is equal to 0. So we put a point as the first term is x value and the second term is the y value. So this point is 3, 0. So 3 is x value, which is also the true set of this downward parabola. So it is here we can check this truth by putting 3 in place of x. This is what you can see here. Minus 2x squared plus 12x minus 18 is equal to 0. Here you can put 3 in place of x. Minus 2 times 3 squared, which is already written here, plus 12 times 3 minus 18 is equal to 0. This is 18, 36, and minus 18. Of course, 0 is equal to 0. So we have a truth statement, that is 0 is equal to 0. So the truth value of this parabola or quadratic equation is x is equal to 3. It's already said here. Real solution means a value of x which is a solution and a member of the set of real numbers. Once again, we can have to see the understanding numbers. We have a different lesson on this number theory things. So this solution set is a real solution set. In a quadratic equation, if a quadratic equation has no real solution, it will always have a complex solution. So what's a complex solution then? That means it's also another set of numbers which are not real numbers, and then which is another set of numbers which has got its own form and definition, as we can see it up here. The complex solution will have the form of z is equal to, this is a complex number. The complex number z will have the form of a plus bi, where a and b are elements of real numbers. They are simply real numbers. And the I, which is called the iota, has got a value of square root of minus 1. Normally in real numbers definition, the square root of minus 1 is not defined. There is no negative number in the square root which we define, okay? So in the complex number domains or world, we can still have a value in which the square root of negative 1 is I. So we can have again to see the solution sets of a certain quadratic equation in which they have a solution set but which is not real number. In that case, we can have a complex number of the form a plus bi, such as 2 plus 4i, something like that. We can still say that a quadratic equation can have a complex solution set or a truth set. Some more characteristics of these graphs here as a start point. The domain of an equation is a set in which we are looking the solutions from. If we are looking at solutions of a quadratic equation from the set of real numbers, which is symbol R, then any complex solutions considered to be invalid, and we only take real solutions of the equation as solution sets of any available, if any available. This is what I want to say here. Any equation has a solution set. That is the truth. Especially in case of a quadratic equation, any quadratic equation has a solution set. But in some cases we say there is no solution. That what we mean is there is no a solution of real number. We can still have a solution of a complex number. That is possible. So that is the definition of it. No solution set means no real solution set. So what we have to say, the correct term of saying it has to be no real solution. That's it. Or otherwise we have complex solutions. So we will have more to say about this one later on, so no need to worry at the moment. A little more tip in here that may help when we go to solving a quadratic equation using the graphs. This graph has no x-intercept. You can see that the graph is coming all the way here. When it reaches to y is equal to 2, it moves up again. The remaining things, it keeps moving up. It will never come back because it's only a 2-degree equation. A 2-degree means a quadratic equation. By the way, looking into the graph, you can tell the degree of a graph. The second degree graph will have 2 times to change its direction, or I can say 2 directions. I can just use colors to show you some characteristics of these degree graphs. Looking into the graph, you can tell the degree of the graph. For example, I can have red one here. This graph is all the way coming down here. One move of the graph. Now the graph is again moving up here. The second move of the graph. So this graph is having two moves. One is the red one here. Another one is the blue one here. So this is one and this is two. This is a second degree graph. Second degree means x squared. So second degree graph. As the equation is of a quadratic equation of the form x squared plus bx plus c. Now it finishes the degree. Once it come up down here, then it go up. It will never come. When it is a third degree, we expect it to come back again. When it's a fourth degree, we expect it to move back again. For example, of this graph. This graph is of a fourth degree, x to the power of 4. This graph, 1, 2, 3, say 1, 2, 3, 4, 5, 6. This is a 6th degree graph. The equation of the general form of the equation of this graph is definitely x to the power of 6 plus, say a, b, x to the power of 5 plus c, x to the power of 6, whatever, 4 here, whatever, then x 3. Some of the coefficients can be 0. Then when they are 0, so the whole term will not be there. But for sure, there is a term x to the power of 6. Because that is a 6th degree graph. It must have the highest degree of 6. So this graph will never come down. This graph will never come down. And then it will never touch x-axis. A graph which is never touching the x-axis will be having no real solutions. When we want to solve quadratic equations, we will be having 4 techniques. One is solving quadratic equation by factorization, solving quadratic equation by completing square, solving quadratic equation by using quadratic equation formula. This is, we call it using quadratic equation formula. However, it is just the same thing as solving quadratic equation by completing square. Instead of applying completing square process for each and every equation, it is much easy to use a variable ax squared plus bx plus c is equal to 0 once and for all, and we solve the solution sets, the truth sets of this equation. Then we will be having a solution set in terms of something like minus b plus or minus under radical square minus 4ac divided by 2a whatsoever. This thing looks like complicated, but it's nothing. It is just only using solving quadratic equation by completing square. So these two are the same, but using the solving quadratic equation by completing square method, we try to bring a formula that helps us to solve quadratic equation, and we use the formula instead of using completing square every now and then. We just use one formula as long as we remember it. The thing is that we have to remember this throughout our life because it's everywhere in different sciences. Thank you. The other one here, solving quadratic equations by using graphs. This is the last option, but it's much interesting. More visual things to analyze and to understand. Let's go to the next page. Now we start solving quadratic equation by factorization. But before we begin to solve quadratic equations using factorization, we need to practice how to multiply linear expressions such as ax plus b and x minus b. Can we multiply these two linear expressions where a and b are real numbers? We normally say real numbers. They can also be complex numbers as we go on. But we just simply say constants is much easier because a constant can be a real number. It can be also a complex number. And we need to know how to apply the multiplication process, especially the very important characteristic of distribution of multiplication over addition distribution of multiplication over subtraction. Let's see one thing here. If we have a variable x and x times x is, as we have stated, x means x to the power of 1, x to the power of 1 times x to the power of 1. When we have a multiplication of two variables like this, we can add the exponents here. X to the power of the exponent here, 1 plus 1, which is x squared. So the quadratic equation format or formula x squared is simply obtained by the product of two x's. That's the thing here. Note number 2. Distribution of multiplication over addition. This is important. If we have here a constant, to multiply it with an expression here, what we do, this constant has to multiply one after the other, both expressions within the bracket or the parenthesis. Then the major symbol or operation, in this case is addition, has to remain there. So a is a common multiplier for both x and b. So first thing what we do, a multiplied by x, addition is there. The second thing we do, a multiplied by b. This is what we do. So a times x plus b is ax plus ab. Let's give it an example here. 2 times x plus 4 is 2 times x plus 2 times 4, which is 2x plus 8. 2 times 4 is 8. Another important characteristic here, distribution of multiplication over subtraction. When we have a multiplied by x minus b here, which is ax minus ab, it's also very clear to see and understand. Let's go to the next one. Again, it looks like a bit wider and complicated, but it's not, honestly. When we have two linear expressions, ax plus b, multiplied by another one, ax minus b, for now I just put it minus b. I can also put it x plus b plus x plus b, which I have it here. We will see that as well. Now what we do here, using ax, I do one multiplication with x minus b. The second one, using b, I do another one. How I do it? Using ax, I will have ax minus b here, plus, this is this plus here, plus, using b, I will have another ax minus b, because this ax minus b is a common multiplier for ax and plus b. Ax and plus b, we can consider like ax and plus b, which is ax plus b actually. But whenever b comes, b has to come with positive value in this case, which is this one here. That's what I want to say. So here, ax times ax is ax square. Ax all in bracket square minus axb. Here we have a plus here, plus bxa. Here is I have a minus here, minus v square. Fine. What can I do then after this? I leave it as it is, this part, x squared minus abx. This is also plus abx here, minus abx. Bax is the same as abx. We call this one commutative property of multiplication. If you multiply two numbers, you can multiply them in any order. Say 2 times 4 or 4 times 2, something like that. This property is commutative. This commutative property works for addition and multiplication, but it won't work for subtraction and division, in fact. Anyway, here, minus abx, here another one, plus abx. These two are of the same magnitude but of different sign. One is a plus, one is a minus. This is a difference of the same number. A difference of same number means 0. 8 minus 8, 0. 10 minus 10, 0. So we don't have this part then here. So what we have, ax squared minus bx minus b squared is all we have. Is all we have. So we need to know the process of doing this one. So for example here, 2x plus 4, 2x minus 4. We have a 2x here, 2x minus 4. What we have done here is we simply bring the difference of two squares formula instead of worried to match up here. I didn't do this multiplication here, but I simply say here a plus b times a minus b means a square minus b square. This is one simple difference of two squares formula. What does it mean? Here I have 2x plus 4, 2x minus 4. 2x squared is 4x squared, because all together 2x all together has to be in a square. So 2 squared is 4, x squared is x squared. Here I have 4, that's 4 squared is 16. 4 times 4 is 16. So this is a difference of the 2. I will take this minus here. So 4x squared minus 16. Okay. Okay, here we have another note, a note 4. ax plus b multiplied by ax plus b. Another name for it is ax plus b, the whole square is what it is. Same thing. A number has to multiply by itself. So what we do, same distribution property we can apply. We have ax here. This one is this one here. Then multiplied by ax plus b. This one is this one. We have a plus b here. This one is here. Multiplied by ax plus b. This one is here. Now I distribute this one. Okay. The next thing is ax times ax is ax all together square. Ax times b is axb or abx, whatsoever you can call, or xab, doesn't matter. Another one, b times ax is bax, abx, xab, again doesn't matter. The order is not a problem. The last one here, b times b is b square. So if the order of this doesn't matter, we have one a, we have one b, and we have one x. When we have of the same terms, then this thing we can add these things together, no problem. We have one a here, we have one b here, we have one x here. So we assume these two objects are identical, so we can add them to be 2 of abx. That's there. Then ax squared is as it is, b squared is as it is. So ax plus b the whole square is ax squared plus 2ab plus b squared. Not a problem at all. Let's see this one. When we have to multiply these two here, these are the same thing. 2x plus 3 and 2x plus 3. It is just like a plus b, a plus b. We have a simple formula here. A squared plus 2ab plus b squared. Easy. So this square, 4x squared plus 2 of this and this. 2 of 2x is 4x. It means what? 2 of 2x and 3. Then the last one plus b squared. 3 squared, which is simply here. 2 times 2 is 4. And I have another 3 there. That's 12x, okay? So that's why it is 4x squared plus 12x plus 9. So we need to practice such and such things here. Now let's do the first technique of solving a quadratic equation, which is called method of factorization. Let's see one example here. This equation is a general form, in the general form of x squared plus bx plus c. Remember, every time we have a quadratic equation, we make sure that we have to put it in this format. What does it mean? If we are given x plus x squared plus 4, this is not the form of a quadratic equation. We need to bring this one in the front here. Here, x squared plus, this is the next one here, x plus this is the next one here, 4. We need to practice to arrange quadratic equations of the form ax squared plus bx plus c. So we have this equation, yes. Is it in the form of the general quadratic equation expression? The answer is again yes. That's just fine then. Now, if it is true, we will get the three values of the equation here. These are a, b, and c. A is the leading coefficient here, the coefficient of x squared. There is nothing, means it is number 1 here. 1. B is here, minus 7. C is here, 12. Once we have A, B, and C, we try to see or to find two numbers in which their product is AC and their sum is B. What do I mean by here? Can we give two numbers in which when we multiply them they give us 12 here? Say these are P and Q. P and Q. When we multiply them, it gives you 12. When you add them, P plus Q, it gives you minus 7. Multiplication gives you 12. What are these two numbers? So this is just one of the techniques to find out two of the factors, and then we write it in that expression. Can we find such two numbers in which their product is 12 and their sum is minus 7? Such two numbers are minus 3 and minus 4. Minus 3 times minus 4 is plus 12, it's here. Minus 3 plus minus 4. Minus 3 plus minus 4 is minus 7 here. Now we found the two numbers. Great. What we do next? We split the middle term into these two numbers. That will not affect the value of the expression. We will see in the next page. Now what we do? We split minus 7x into two places. These are minus 3 and minus 4. So here minus 3x minus 4x is minus 7x. When I split the middle term into these two numbers, the expression won't change because I didn't give anything extra. I only split the middle term into two places. And perform the reverse process of the distribution property. Anyway, we have this distribution property and other properties there. That's important. We are doing it here in the reverse order, so it's easy to understand it here. What is the equation? The equation was x squared plus 7x plus 12 is equal to 0. Now we split this one into two. X squared plus, oh, this is not plus here, a minus, sorry. X squared minus 4x minus 3x plus 12 is equal to 0. That's fine. Now, what we have done is we split minus 7 into two places, minus 4 and minus 3. This won't change the value. But can we see anything in common in between here, between x squared and 4x? What is the common thing they have both? X squared is what? Xx. 4x is 4x. What is the common thing between xx and 4x is 1x here. That's fine. So let's take 1x here. This 1x here, I put it here. What is the remaining thing? Here, actually, I'm taking it in the reverse order here. Here, so I prefer to continue on my way here because we end up with the same result at all. No problem. So let's come back here. I take x as a common, then what is inside here? X minus 4. Distribute and check. X times x is x squared. X times 4 is 4x. That's fine. How about now? Once I have this factor here, because I'm using by factor, that's fine. Okay, let's do this one next one. What the second part of this expression is minus 3x plus 12. Okay, what is 12 in fact? 12 is 3 times 4 minus 3x plus 3 times 4. Do I have again something common between these two? That is just minus 3. I can call it 3, but I can call it also minus 3. At that time, this value will change because here is x minus 4. What I have here is x minus 4. I can simply put this x minus 4 here, and I still have minus 3. That's it. Minus 3 times x, minus 3x here. Minus 3 times minus 4 is 12 here. So that expression is what? X into x minus 4 minus 3 into x minus 4. Now I have here this one. The other way also, it is the same thing here. Now this step and this step are equivalent. The next thing I do, can I see something common between these two expressions? Yes, I can see x minus 4. If I see x minus 4, I take x minus 4 now again here. And what is inside remaining? I have 1x here. I have minus 3 is here. Yes? So now the expression is x minus 4, x minus 3. Okay? But the equation is saying what? X squared minus 7x plus 12 is equal to 0. So I should not forget is equal to 0 up here also. In that case, x minus 4, x minus 3 is equal to 0. The product of two expressions is equal to 0. When is the time we have a 0 in a product? When we multiply two numbers and we get a 0, that means at least one of the two numbers is 0. At least one of them. So which one? X minus 4 is equal to 0, or we don't know which one. X minus 3 is equal to 0. That means when x is equal to 4. This is going to happen when x is equal to 4. Or this is x minus 3 is 0 when x is equal to 3. Because we are interested in the value of x, but not the value of x minus 3, then we have to find out x's. So this is true when x is equal to 4 or x is equal to 3. Or means, in other terms, a union. We combine together. So this solution set, for me, it comes to be 4, 3. Here in the previous calculation here, 3, 4 is the same thing. 3 and 4, 4 and 3. This is the same thing. Two elements, 3 and 4. That's just fine. Let's see another example here. We just follow this one. The order doesn't matter, as we have said. Once we have the two numbers, we can use any expression such as 2x plus 3 or x plus 1. In other words, x plus 1 or 2x plus 3. Whichever comes first doesn't matter. That's what I'm talking is what we see here in this example here. In our case, x minus 4 comes first. In the previous example, x minus 3 was there. See here? X squared minus 4 is how I start with. But here, x squared minus 3 minus 3x. X squared minus 4x. Doesn't matter. In both cases, we end up with the same solution set. Here, another example. 2x squared plus 5x plus 3 is equal to 0. It's easy. Is it in the general expression of a quadratic equation? Is the first question. The answer is yes. If that's the case, what is A? A is 2, B is 5, and C is 3. What is A times C? A multiplied by C. A multiplied by C is 6. What is B? B is 5. Can we find the two numbers in which their product is 6 and their sum is 5? Yes. What are these two numbers? 2 and 3. Check. Is 2 times 3 6? Yes. Is 2 plus 3 5? Yes. Now, what we do, the next thing is that we split the middle term into these numbers. So what is the question? 2x squared plus 5x plus 3 is equal to 0. What's the middle term? 5x. Can we split the 5x into 2? Yes. What and what? 2x and 3x. Do we really change the equation? No. Why? Because we only split the middle term into two parts. We didn't add or subtract anything out of it. That's just fine. So 2x squared plus 2x plus 3x plus 3 is equal to 0. First thing we do, we try to see a common term between these two, which is 2 is yes, 2 and x. 2x squared is 2x squared is 2xx. Okay? Another one, minus 2x, minus 2x. We can see this and this is a common term. So when I take 2x here, I will have x plus 1. Because here, I still have 1 if I want it. I still have 1. So when I take 2x, I have x plus 1. If I have x plus 1 here as a factor, I will automatically put it here first. Doesn't matter. I put it here, and I try to find out what I have to put here. If I put it here as x plus 1, I know that I have to put 3 here, because 3 times x is 3x, and then 3 times 1 is 3. Now, what is a common for this one and this one is the next thing, which is x plus 1. X plus 1 is a common thing. When I take x plus 1 here, I will be having 2x plus 3. So I have 2x plus 3 and x plus 1. So these are the two factors of the original quadratic equation. This is a method of factorization. The two factors are 2x plus 3 and x plus 1. These are the two factors. So the product of the two factors is 0. That means 2x plus 3 is equal to 0, or x plus 1 is equal to 0. In this case, 2x is equal to minus 3, which implies x is equal to minus 3 over 2, which is said already here. And in this case, x is equal to minus 1. The two solution sets of this quadratic equation are minus 3 over 2 and minus 1. This is a graph. That's fine. Let's add a little bit more on this one. This is a graph. Is this graph upward or downward? This graph is an upward graph because the leading coefficient is positive, just fine. So this graph is just like that, okay? Will it intersect with the x-axis? The question is yes. The answer for this question is yes. Why we say yes? Because we have two real solutions. One is here, x as minus 3 over 2. X as minus 3 over 2. Another one is x as minus 1. This is where the graph is. We still have x is equal to, just like that, we still have x equal to 0. 0 is here. So this graph is shifted to the left of the y-axis. It doesn't matter. We will have to see more on this one with different graphics. So no need to worry about that one now. Next page. Here we have one expression, which is x minus 2 over 3 is equal to 5 over x. Here, before we proceed, we need to set the domain as the term 5 over x, this one here, will not be defined when x is equal to 0. Can you see this one here? When we say 5 over x here as an expression, can we put x is equal to 0? That we will have 5 divided by 0, which is not defined, right? So whatever solution set we can get doesn't matter. But if that solution set is 0, it will not be a valid solution set. We need to keep in mind that one. So the domain for this equation means where we look at the answer from is from any real number, but never be 0, different from 0. Okay. Now this term is not in the general quadratic equation expression, so it needs some rearrangement on that one. For this, we need to have one little formula here. A divided by B is equal to C divided by D, or A over B is equal to C over D. When we have such an expression, we can simply multiply these two, which is AD, is equal to these two, BC or CB. AD is equal to BC. With that, what we have to do, we multiply these two, x and x minus 2, we multiply these two, which is 15 here. But x and x minus 2 is x squared minus 2x. So the equation is x squared minus 2x minus 15. Why we put minus 15 here? Is equal to 15. When it comes to the other side of the equality sign, it has to change its sign, a plus to a minus and a minus to a plus. So the quadratic equation is x squared minus 2x minus 15 is equal to 0 in the general form. Now we have x squared minus 2x minus 15 is equal to 0. That's fine. Can we find out now the values of a, b, and c? Yes. A is equal to 1, b is equal to minus 2, c is equal to minus 15. Can we find such two numbers in which their product is a times c, minus 15, their sum is minus 2? Yes, these are 3 and minus 5. Check. 3 times minus 5 is minus 15. 3 plus minus 5 is 3 minus 5, which is minus 2. That's correct. Now we have to split the middle term into 2 to factorize it. So the middle term here is 2x. Now 2x has to be splitted into here 3x minus 5x. Yes, 3x minus 5x is minus 2x. It's something like 3 minus 5. So when we split the middle term and see what in common I have here, this is xx, this is 3x. So I have x in common, then 1x extra here, plus 1 3 here. X into x plus 3. If I have x plus 3 here, I put it right there and see what I have to put here. When I have x plus 3 here, 3 will be 15 when we multiply it with 5. 5, and which is negative here. Minus 5 times x minus 5x minus 5 times 3 minus 15. That's just fine. Now what is the common between this side and this side? Which is x plus 3. When I have x plus 3 in common, I will have x minus 5 on the other side. X minus 5, x plus 3 is equal to 0. It means x is equal to 5 or x is equal to minus 3. Remember, x should not be 0. We know that. So 5 and minus 3 are different from 0. So they are both valid solution sets of this quadratic equation. One more example here. A piece of rectangular paper has one side 3 cm longer than the other side. This side, the length is 3 cm longer than the other side. Say here the width. Its area is 28 centimeters square. This part, the area is 28 centimeters square. What are the lengths of the two sides of the rectangle? It's easy, no worries. But what we have to do, if this side is x, we have to start giving a variable here. This side has to be x plus 3. One important thing. The other one, the area of a rectangle is length multiplied by width. Two important facts we have to remember. And the third one is that it is about the length of a rectangle and has to be always positive. Length is measured starting from 0 all the way up to positive. Then x has to be greater than 0, and this side as well, x plus 3 greater than 0. When x plus 3 is greater than 0, x is greater than minus 3. So x has to be greater than minus 3. X has to be greater than minus 3. X greater than 0 and x greater than minus 3. And means intersection. So it is this one here. Inequalities we will discuss at the end. Inequalities of linear equation and quadratic equation. But for now here, x is greater than minus 3. Okay. We keep in mind this one, and now we solve the equation. So area 28 is equal to x plus 3 times x. When we distribute this one, this is x squared plus 3x. X squared plus 3x is equal to area. So x squared plus 3x is equal to area. So the equation is that x squared plus 3x is equal to the area 28. Then x squared plus 3x, move it here, minus 28 is equal to 0. When we move it to the other side of the equality sign, we give it minus, a minus sign. Now we have the equation. Let's do the factorization method of this quadratic equation. Let me come back here now. This is the equation, right? What are the three numbers, a, b, and c? A is 1, b is 3, c is minus 28. Can we find two numbers in which their product is minus 28, which is a times c, and their sum is a plus 3? Yes, minus 4 and 7. Can we check? Yeah. Minus 4 times 7 is 28. True. Minus 4 plus 7 is equal to 3, which is the value of b. That's also true. So let's split the middle term into 2. What was the middle term here? 3x. 3x has to be split into 7x minus 4x. Or minus 4x plus 7x. Doesn't matter in which order we put it, doesn't matter, because the end result will be like x plus 7x minus 4 or x minus 4x plus 7. In any two order, it doesn't matter. So when we split it, it is x squared minus 4x plus 7x minus 28 is equal to 0. Good. What is a common term I have here between xx and 4x? That is x. I have x here, then one more extra x is here, minus 4. X into x minus 4. Now if I have x minus 4, I just put it here. If I have x minus 4, I just put it here and see what fulfills in the upper part. 7 minus 4 minus 28, 7 and x, 7x. That's fine. So I have x and 7 here. I put them here, x plus 7. And then a common term here, x minus 4. So these two products will give you the original quadratic equation. The product of these two numbers is 0. So what it means, either one part of it is 0 or the other. That's the thing. So x plus 7 is equal to 0, x is equal to minus 7, x minus 4 is equal to 0, x is equal to 4. Is this two x value, out of these x values, which one is in the domain? Remember, in our domain selection, x plus 3, which is the side of the length of the rectangle has to be greater than 0, we said, which implies x is greater than minus 3. But minus 7 is not greater than minus 3. So this is not a valid answer. Now we only pick x is equal to 4. But the domain is, in the domain is that x is greater than 0. X is greater than 0, I call it here. In fact, x greater than minus 3 Hence, we only take x is equal to 4. Let me go back here and see this one here, okay? X is equal to 4 as a valid answer. Hence, the width is, remember that side was x and this side was x plus 3, right? So if this side is 4, this side is 7. The area 4 times 7 is 28. That was correct, okay? So the lengths and widths are 7 and 4. Let's do one more example here before we end up this session. This session, in a sense, using a factorization technique. So I better finish this one. It's interesting. So let's put them all together here in one lesson. Here, a right angle triangle has the two short sides, x minus 2, one here, and x plus 5. And the longest side is 2x minus 1. Good. Find the area and perimeters of the triangle. This is a right angle triangle. Once we have the two sides here, I can call them the lengths and widths. The area is equal to half of lengths and widths. That is the area of a right angle triangle. The perimeter is equal to the sum of the three sides. If it has got, say, a length plus width plus, I call it the hypotenuse here. Hypotenuse, the sum of the three sides is the perimeter. So, can we set now this quadratic equation? This one is a right angle triangle, and we need to remember Pythagoras theorem. So a square plus b square is equal to c square. The square of the two short sides, the sum of the squares of the two short sides is equal to the square of the longest side, which is the hypotenuse here. So we have a, b, and c. A square plus b square is equal to c square. A square plus b square, these two, is equal to c square. I leave this one, the simplification of this one for you. And when we go to the simplified form, here are a square, b square, and c square, what equation we are going to obtain? We're interested in this one. This is where we are now, okay? You can pause and have a look in how it goes. So 2x squared minus 10x minus 28 is equal to 0. We can divide both sides by 2. That is true. Because it is the equality equation. In case of equality equation, we can do such operations, no problem. But in case of graphs, we cannot do y is equal to 4x squared. It does not mean you divide by 4 and then y is equal to x squared. It doesn't work. This graph and this graph are different. In case of graphs, we cannot divide by a constant term or anything. But in case of equality equation, we can bring it to a simplified form. That is allowed. So divide both sides by 2 will make it a little bit simpler. For example, 2 divided by 2 is x squared, minus 10 divided by 2 is 5, minus 28 divided by 2 is minus 14. So this equation as an equation and this equation are the same. They will have the same solution sets. But as a graph, if y is equal to this graph and another graph y is equal to this graph will be different. This we will discuss it later. How come they have the same solution sets and of different graphs? That is true because a solution set of a given graph is the x-intercept. So these two graphs can have the same x-intercept. Yes, one could be this way, and another one could be this way. They can have the same x values, but of different graphs. Now, we're interested in the x-intercept. So, we can simplify dividing both sides by a constant number, and we can solve after that. So, we have a, b, and c here. A times b minus 14. A times c is minus 14. B is minus 5. Can we find two numbers in which their sum is minus 5 and their product is minus 14? Such two numbers are here. Minus 7 and 2. Minus 7 times 2 is minus 14. Minus 7 plus 2 is minus 5. Now we have the two numbers. Then we split the middle term, which is 5x. So what we do, x squared minus 7 and 2. 7x plus 2x, then minus 14 is equal to 0. We can put it this way. The common term here, x into x minus 7. I have now x minus 7 here. Then what I have here, 2. Right? Then it's a plus. Then it is x plus 2, x minus 7, something like x is equal to minus 2, x is equal to 7. That's how I put it. But we always, in case of measurements, sides, we always need to see the domains. We have to find out the domains first. And only one of them will be valid. What is the domain here? The domain here, x plus 5 should be greater than 0 because it's a side. X minus 2 should be greater than 0. 2x minus 1 should be greater than 0. From here, x is greater than minus 5. From here, x is greater than 2. From here, x is greater than half. So, the smallest x value is this one here. So, domain, x should be greater than minus 5. So, whichever number which is greater than minus 5 is a valid answer. Which one it is? Let me have a see. Let me have a look once again. X plus 5 is greater than 0. X is greater than minus 5. Okay. X minus 2 is greater than 0. X is greater than 2. X is greater than half. That's okay. Then here, the minimum value in which x has to be greater than minus 5. When we put minus 2 here, x is going to be 3, right? When I put minus 2 here, x is going to be 3. But when I put minus 2 here, it will not work. X has to be greater than 2. So which one? Which x value we have to take? X greater than 2 is what we have to take. Okay? Which length requires the highest x? This one. This one requires the highest x value here. X greater than 2. Because this has to be greater than 0, it's a length. This has to be greater than 0, and this has to be greater than 0. All the three sides has to be greater than 0. In that case, here x has to be greater than 2, x has to be greater than minus 5, x has to be greater than half. X has to be greater than half. So we have to take the larger x here. X has to be greater than 2. So in that case here, minus 2 is not greater than 2. So we only take 7. Now we are here, right? We only take 7. When we take 7, now we can find out the lengths of the length of this triangle. In case of x minus 2, when we put 7 in place of x, we have 5, 12, and 13. Is that true? We can check the Pythagoras theorem on this one. 5 square plus 12 square is equal to 13 square is true. Okay. Now we have the three sides. Area is half of AB, half of 5 and 12, 30 units. Perimeter, you add the three lengths, A plus B plus C. Interestingly, The area and perimeter are the same for this triangle. One more question here, and interesting in fact. An equation of, say, x squared minus 3x minus 1 is equal to 0. A is equal to 1, b is equal to minus 3, c is equal to minus 1, which is here already. A times 3 is minus 1, b is equal to minus 3. Can we find two numbers in which their product is minus 1 and their sum is minus 3? That's a question here. We're going to use a technique of factorization. In this case, we cannot find such two numbers so easy, because these numbers are not even integers. They are not even rationals. Probably they are irrational numbers in some cases. So it's not easy to analyze and find out two numbers in which their product is a times c and their sum is b. Such a thing is not possible. So a technique of factorization is not solving all kinds of quadratic equations. It can only solve quadratic equations in which the factorization terms are integers and easy to be figured out, which is not always possible. In that case, the technique of factorization is not an end technique to solve all quadratic equations, and we need to have another technique. I only say we need to have another technique at the moment because the next video is showing us solving quadratic equations by completing a square. That's very important one, and that helps to solve any kind of quadratic equations. So we need to see that one. Before we go to that technique, here is an exercise which we have to work that will help us to test ourselves if we really understood what we have discussed in this session. So this is exercise in which you try it, and then if anything difficult, you just put a comment and we work it all together. It doesn't matter. And thank you very much for watching this 1 hour and 12 minutes of video, and I will make it much better and better. Subscribe and stay tuned with me. Thank you so much and have a good time.